Hello students, welcome to a study doubt. This question is from physics chapter nuclei. In the question it is given that a coin has a mass of 3 gram. We have to calculate the nuclear energy that would be required to separate all the neutrons and protons from each other. For simplicity, we assume that coin is made up of entirely copper atoms and its mass is given as 62.92960 U. So the mass value that is mentioned in the question, so this mass is actually the experimental mass value. So m dash, this is for per nucleus. Now let's look into the question. In the question it is given that we have a coin and its mass is, total mass of the coin is 3 gram. That's given in the question. And inside this coin there are copper atoms present. We don't know how many values of the number of copper atoms, but copper atoms are present. Only copper atoms are present. So each of the copper atom, let's assume this is a copper atom. So this copper atom atomic mass is 63 and atomic number is 29. We have to remove the number of protons and number of neutrons from each of the atoms. So the energy that is coming out is our binding energy. So we need to find the binding energy for each of the atom, or you can say that binding energy per nucleus. But in the question, we have to find the binding energy for complete coin, not only for one atom. We have to find the total number of atoms binding energy. So for that, what we are going to do? If we find the binding energy per nucleus and we multiply with the total number of atoms, so from there we can find the how much energy is required to break it, or the nuclear energy required to break the neutrons and protons. So for that we need to first find the number of atoms, and we also have to find the binding energy per nucleus, and then we multiply both of it, we get the total number of nuclear energy. So let's solve this question. So here in the question, total mass is given as 3 gram, and according to the question, atomic mass of the copper is given as 62.92960 U. But this is in U and here it is in gram. So both are in different units. So we have to convert it into the same unit. So this total mass can be written as 3 into 10 to the power 3 kg. And how we convert this U to kg? So there is a conversion. 1 U is equal to 1.66054 into 10 to the power minus 27 kg. The mass of one atom of copper is 62.92960 into 1.66054 into 10 to the power minus 27 kg. So now if we multiply, mass of one atom of copper will be equal to 1.0456 into 10 to the power minus 25 kg. So this is our atomic mass of copper in kg, and this is our total mass of the copper. Now if we have to find the number of atoms, number of Cu atoms, so for that we are going to divide total mass by the mass of one atom of copper. So it is 3 into 10 to the power 3 kg, this is minus 3, divided by 1.0456 into 10 to the power minus 25 kg. So it can be written as 2.868 into 10 to the power 22 atoms. So total number of atoms, we found it, which is present in this one coin whose mass is 3 gram. So this is our value. Now we got the number of atom. Now we have to find the binding energy. So for finding the binding energy, we use the symbol EB. per nucleus, it's equal to EB is equal to delta M into Cs square. So here delta M is the mass defect. This is the mass defect. What is mass defect? Mass defect is equal to the difference of the theoretical mass minus the experimental mass. Experimental mass is already given in the question. This is our experimental mass that we already discussed. Now we have to find the theoretical mass. So how to find the theoretical mass, this M, how to find this M? So this M is equal to number of protons into mass of proton plus number of neutrons into mass of neutron. This relation we can use it. So how to find the number of protons and number of neutrons? So we know that copper atomic mass is 63 and atomic number is 29. So this is our Z and this is A. So we have to find the number of protons and neutron based on this information. So let's find the number of proton. So we know that atomic number, it's Z here. It is nothing but the number of proton and its value is 29. And A is equal to number of proton plus number of neutron. So A value is how much? 63. 63 is equal to NP is 29 and N. So number of neutron is equal to 63 minus 29. So we can say that number of neutron is equal to 34. Now we have number of proton and number of neutron. What about the mass of proton and mass of neutron? So mass of proton and mass of neutron value is always fixed. Mass of proton is equal to 1.007825 U and mass of neutron is equal to 1.008665 U. So these two values we can substitute in the given here, and number of protons and neutrons we already found it. So now if we have to find the theoretical mass, we can substitute the value. Number of proton is 29 into 1.007825 plus 34 into 1.008665 U. Now the theoretical mass is equal to 29.211004 plus 34.29461. This is our U. It's equal to 63.505614 U. So this is our theoretical mass. And experimental mass is already given in the question. So if we have to find the mass defect, it's equal to delta M. It's equal to theoretical mass minus experimental mass. So theoretical mass is 63.505614 minus experimental is 62.92960. Delta M is equal to 0.576014 U. So this is the mass defect we got. Now we have to find the binding energy. So EB is equal to delta M into Cs square. Delta M is equal to 0.576014 U into Cs square. C is the speed of light. So here we can use another relation. 1 U is equal to 931.5 MeV by Cs square. If we use this relation, our calculation will become more easier. So directly we can write as 0.576014 into MeV by Cs square into Cs square. So Cs square gets cancelled. So our binding energy is equal to 536.7 MeV. So this is the energy with respect to per atom. And now we have to find the total energy. So total energy, if we have to find, we need to multiply with binding energy and the number of atoms. So let's solve it. EB is equal to 536.7 MeV into number of atoms. Number of atoms, we got it as 2.868 into 10 to the power 22. So if we multiply it, it's equal to 1.539 into 10 to the power 25 MeV. So this is our total energy required. If we have to convert this energy in joule, we have to multiply with 1.536 into 10 to the power 31 EV into 1.6 into 10 to the power minus 19 joule. So E is equal to 2.47 into 10 to the power 12 joule. So this is the answer. Both answers are correct. Only the conversions are different. So answer will vary. If you have any doubt in this question, you can mention it in the comment box. I will try to resolve it. Thank you so much.